Assalamualaikum and good day to everyone. My name is Noorolpadzilah binti Haji Muhammad Zan. Today I will present my study entitled Design and Development of a Microcontroller Control IoT Based Multimeter. Before we start, let's take a look at the contents of my presentation. First, we go to the introduction of my study. Then, we go to the problem statement. Next, objectives. Next, material and methods. Result and discussion. Conclusion. And the last one, references. Let's start with introduction. When measuring electronics components or electrical circuits, it is essential to use electronic measuring devices. A multimeter is measuring equipment that is commonly used to measure electrical quantities or components. A multimeter can be categorized into two types, the analog multimeter and the digital multimeter. The use of a multimeter can be elevated to a new level with the help of modern technologies and the Internet of Things. With some elements of the IoT in its function, the learning experience with the multimeter can be improved when the measured value from the multimeter is displayed on the mobile phone application. The use of mobile phone applications in teaching and learning provides positive ideas and benefits that motivate students to learn and understand more effectively. Therefore, in this paper, an approach of reading the multimeter using the IoT is proposed. Next, we go on with the problem statement. Before the project was implemented, the main problem faced by lecturers and students in the teaching and learning process was that students took a long time to complete their work due to the problem of identifying circuit problems and performing circuit measurement tests using analog multimeter. Usually the circuit is not functioning because there is an error in the connection of the circuit. Students encountered problems with the protobot test point which caused the circuit to fail even when the circuit connection was following the given schematic circuit. Students are less proficient in reading analog multimeter and remembering the basic theory of measurement that needs references notes during the practical work. The objective of the research are to design a multimeter based on Internet of Things concepts. The second one, to develop the IoT multimeter that can communicate with the mobile phone. And the last one, to facilitate the process of teaching and learning session. This is the overall block diagram for the project. The whole system is controlled using the Arduino Nano microcontroller system. 5 other circuits are built to support the measurement value for the microcontroller to process: resistance circuit, voltage circuit, current reading circuit, protobot checking circuit, and the continuity circuit. A selection switch is placed to control the input choice for the user to select. The system uses a 5-volt power supply. A Bluetooth HC05 module is used for the communication between the microcontroller and the mobile phone. To enable the Android mobile phone to display the needed data, custom-built application software is built using the MIT Apps Inventor tool. A flowchart for the whole operation system has been built. The system starts when the user chooses the selection switch on the front panel of the tester. This selection switch can be used to select a different type of testing. After selecting the proper measurement type, the user can put the testing pin in the test area. Next, the user has to turn on the Android application on the mobile phone. Establish the Bluetooth connection between the mobile phone and the microcontroller control IoT-based multimeter. The last part is where the user will get the value of their measured item on the mobile phone. The hardware of microcontroller control IoT-based multimeter consists of basic control panels of a normal measurement tester. At the front of the panel, there are two LED lights to represent the power LED, which is green in color, and the system busy indicator represented by the yellow LED. At the bottom left of the panel is the 5 test pins that are being used to test the protoboard continuity. Besides the protoboard test pins, there are two different types of the test point. This test pin is used for the same purpose. The smaller male connector is used to connect the test cable to the protoboard, while the bigger female connector with red and black color is used to connect to a test probe. At the top right of the panel, there is a selector switch. Users can select C to test the continuity of a circuit, V for testing voltage, A to test the current flow, and ohm to test the resistance. To test the protoboard continuity, a user must set the selector switch to the off condition. At the side of the panel is power switches that can be used to power up the whole system. The power supply uses a 9-volt battery that is put inside a container at the back of the box. A custom circuit has been built to support the functions on the Arduino Nano to measure multiple types of measurement. 5 circuits has been used to measure the protoboard continuity, resistance value, voltage, and current flow. The input for the circuit is controlled using the selection switch that enable the user to select their preferred measurement. This circuit does not include the Arduino Nano microcontroller and the Bluetooth module circuit. The algorithm for this project is built using Arduino software. The structure of the programs is divided into 5 subroutines. The first one is voltage subroutine, the second one current subroutine, and then continuity subroutine. The fourth one is protoboard subroutine, and the last one is resistance subroutine. This is the main view of the Android application software. This software is used to connect a mobile phone to a microcontroller control IoT-based multimeter microcontroller board using Bluetooth. The mobile phone will act as a screen to read the measurement value. 6 buttons that can be pressed on the main page of the software: Bluetooth connection button, protoboard selection button, resistance selection button, continuity connection button, voltage connection button, and current connection button. Using this entire button, the user can monitor the value of all the measurement that has been made. Using this button also, there is a sub-menu can be selected by the user to monitor every theory that is related to what the user is measuring. This is the results and discussion for the project. Figure 1 shows the finished product of the research. It can be seen that there are 2-part microcontroller control IoT-based multimeter. The first one is main device and the second one is Android applications. A comprehensive test has been done for all the abilities of the system. All the type of measurement is tested with a random test value. The test result shows overall the percentage of differences between the test value and the real measured value is less than 10%. This means that this multimeter is a reliable tester that can be used to test all types of measurement that it was built for. The percentage for the resistance measurement is rather high than other measurement. This is because of the auto-ranging system that has been built for resistance measurement. To match the test resistance, the system simply uses 7 references resistor values. The accuracy can be increased if the reference resistor is added. Here are 4 types of circuit testing in the microcontroller controlled IoT-based multimeter display that can be seen on the mobile phone. Protobot testing, resistance testing, voltage testing, and the current testing. Additional reference notes are included in the app's development for the mobile phone to make it easier for users to make quick references. For the conclusion, for this project, this work is targeted to help to ease the process of learning using the multimeter while using IoT to enhance the learning ability. The usage of Arduino family software and hardware has been the popular choice of microcontroller technology enthusiasts nowadays. The ability of Bluetooth technology has helped to implement the concept of IoT in the system. Using the MIT Apps Inventor tool, software has greatly reduced the time and the inconvenience of building the software application for the mobile phone. It helps a lot of beginners to build custom software to be used as an interface. The microcontroller controlled IoT-based multimeter is successfully built and tested, and it is surely help to develop knowledge for the user as it is combined with theory concepts in Android applications. That's all. Thank you.